Right, here we are back again, and this is that little Lucky Chance randomizer type kit thing, and I thought I'd have a go at this. It's just a nice, well, it's a little diddy project. The only thing with this particular one is it uses surface mount devices. So all those people who say, surface mount, can't deal with it. Well, my old eyes can see, and I need glasses now to actually see anything close up. If I can still do it, I'm sure other people can. What have we actually got here? So we've got capacitor, a whole load of LEDs, 2 ICs, a transistor, 4 resistors, and that looks like a diode there. So again, let's just bring the board in and focus on the board. Okay, let's try and get the light off it. As you see, nice clear print for what it is, and it actually has the component numbers marked on them. So there's very little that, focus back again, there we go, that we can go wrong with. So I think in this case we'll just go ahead with soldering on and go that. Now this is an NE555, so same as the standard 8-pin DIL chips, but in a surface mount package. So in this case I'm going to need the tweezers, because I can't hold things that small and solder at the same time. So let's take that out of its packet first. Let's turn it over and figure out which way up on the board it goes. So there's the notch, and you can just about see the dot. So let's lay it on the board. Okay, now here's the fun bit. If I rest the tweezers on the top like that, we should be able to get the first leg soldered on, and one of these back legs like that. Just check that it's on straight. Yep, it's not bridging tracks. So then we can do the rest of the legs. So if we just go down the side, managed to bridge that. I'm not using the smallest tip that my soldering iron's got, and I could actually get that out for this sort of work, but I'm just trying to also show that the standard stuff most people have is just as good as going out for specialist soldering irons with very fine tips. I think the smallest tip I've got is a 0.2mm tip for this surface mount work. As you see, we'll go for the next chip, but we'll try and get through the plastic. There we go. Just get it underneath, and then I can unhook it. Now let's turn it over, and this is a CD4017 as well, so this is a decade counter as well. So very similar to the flashing police light chip. Now, without having the circuit diagram to hand, what I guess this is doing is, instead of having the reset line so that it resets back to the first pin once it's counted, it just counts on from where it left off. So let's just, again, put that on there. And I'll do one of the ones closest to me. goopy. But, yeah, let's just check that that's all straight. Yes. So as you see, you know, nothing. Surface mount devices they're here to stay. I don't think we're going to get away from that. So I think, in fact, what I should have done is probably put some flux on the board, because it doesn't seem to be flowing as well. Mind you, I haven't cleaned the board. Maybe what I should have done was just run some degreaser, some isopropyl alcohol over it to clean it up. Take off any of the finger grease or the manufacturing byproducts, just to make sure that the board was perfectly clean. Okay. Again, although my eyes are going, I will still give it a quick check. Magnifying glass, nothing's bridged, so that looks good to me. So let's go with the transistor now. So again, whereas the police flashing light had 3 output transistors, obviously because this is just wanting to drive a single LED at a time, then you only need the one. Now that is quite small. Where does it actually go? It goes there. So let's just turn the board round. And put it there. And again, just rest the tweezers on it. Moved it completely. Oh, chasing components around circuit boards is fun, isn't it? Right. Don't let the spring work, just do that. This might be one of the outtakes of the video. I might put that up. Let's just try not to drop it everywhere. Okay. Now sit and stay. Maybe I should just, rather than put the tweezers on it, let's just see if we can flow a bit of solder up one of its legs. Like that. Yeah. And check that the others are contacts. Yep. There we go. Just check that that's in place. Yep. Whew. Right. Diode next. Again, as per the flashing light, blah blah. Sounds like I'm repeating myself, probably because I am, probably because the circuit is almost going to be physically identical. Remember I said in the flashing lights video that there were 3 identical circuits just being driven. Well, this is let's say one identical circuit being driven, or a circuit being driven. Right, there's the diode. Where's that go? That's where S1 goes. That's where the diode goes. There, like that. Yeah, get off the iron. Right. Okay. Pinged it across the bench now, so I've got one bit of pad. If I was going to do an outtakes video, this is the one to take the outtakes from. And now it's gone on the floor. Back in a moment. Right, here we are back again with the errant diode. Which is now soldered in place at one end. So it shouldn't fly off any further. No, it didn't. Right. So now we have two lots of 4 resistors. There's a 470k according to the board, and what else? 10k's. So if I look closely at this, 474, so that's 47 with 4 zeros. So 470k, that's correct. Let's just lift that up. Okay, now again, as long as I don't have the same issue with the diodes, 470's there. In fact, what I'm going to do is I'm going to melt one blob of solder on each of those pads. There should be one more. 1, 2, 3. As they're giving us an extra resistor, or yeah. Okay, so this is the 470, so there. And the other 470, let's just turn it over. And pop it in there. So 10k. 12. 470. There's nothing on the back of the board, no. So, so we've got one extra resistor that we don't need. Well, that's fair enough. I'm not going to complain about that. Can go with my stock of other bits and pieces. What I'll do is I will only release 1/2 of the packaging. Right, okay, so let's keep rubbish, 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 bits of rubbish, okay. So then we've got the LEDs, bringing the trusty tester. Yep, and which way are these going? Positive towards the centre. I know it seems like a chore to test them, but teach me to put it in the wrong way round. It should work, yes. When you put the diode in the right way round, it works. When you put it in the wrong way round, it doesn't. See, the fingers on this strip is getting a bit worn. I might have to take it apart and repair it at some stage. Just keeping an eye on the camera, I don't want it to drop out on me. Battery's still good, yep. Oh, go on, positive, negative. I've got an extra LED as well. Looks like it. So let's turn that way round. Bring it more to the centre so that it's more in your view. What happens when you don't leave the heat on long enough. Your solder sticks to the component. But, it is a careful balance, and you do get used to doing this. Right, just clip all of those off. Okay, so what have we got left? We've got 47 microfarad, which goes in there, positive to there. Leaves this one, which is a 1 microfarad, same as in the last kit, to go in there. Let's just blob them in. Yeah, this board seems to be a bit greasier, which is why the solder's not flying as well by the looks of it. There we go. I'm just going to straighten that up a bit. For now, and then we have the switch, which goes in that way round physically. Okay. Come on, warm up and sit. Okay, and the header pin for the power, which Do you really want the power lead? See, I don't know. Could have put them on the other side of the board, but let's just poke that down like that. Let's make that go in properly. Okay, so there we go, project completed. Let's try it out, shall we? And what I'm going to do, because I'm using my crocodile clips, I'm going to bend those out slightly. So positive is on this one and negative is on this one. They're not touching, but they're obscuring the LED. But in fact, if I put this one over through that LED there, then we can still see what's going on. Right, let's bring the voltage down to about, let's start with 5 volts, I think, and bring the current up. There we go. A randomizer. There you are, a 1 to 10 random counter. And all in, what's that? 10 minutes at the most. 10-12 minutes at the most, with a couple of seconds spent me crawling on the floor for the diode that went flying. So there you go. Eeny, meeny, miny, mo. Who's going to come up next? 3. There you are, 6. So there you go. Another little lunchtime project. Thanks very much for watching. See you all soon.